Okay, we're going to look at inequalities and systems of inequalities. And the way that we want to graph these is as if they were an equation, x squared plus y squared equals 16, and then consider what the inequality is doing. Because what's happening is you're still trying to have a picture. When we say graph, it's a picture of all of the things that will satisfy that equation, or in this case, inequality. So if we look at just the equation x squared plus y squared equals 16, there's a ton of ordered pairs that satisfy that equation. In fact, if we graph that, which I know that that's a circle with a center at 0, 0, and our radius is that 16, radius squared is 16, so r is the square root of 16, which is 4. So if I plot that 0, 0, and then I go 1, 2, 3, up 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. If I connect those dots, what I'm drawing for you right now is the set of all points that make that equation true. So if I, in particular, go to that top point, 0, 4, I know that it will satisfy that equation. If you don't believe me, we can check that. We're looking at 0 squared plus 4 squared, that's supposed to equal 16, which it does. And so every point on this graph is going to satisfy that equation. So what we're looking at now with inequalities is actually a bunch more solutions. So when it says x squared plus y squared is greater than or equal to 16, we're looking at ordered pairs that will make a quantity that is not just equal to 16, but bigger than or equal to 16. So if you think about what that might look like, if I pick a point outside of my circle, let's look at this point right here. This is 6, 0. Let's check and see if that satisfies the inequality. So we have 6 squared plus 0 squared is supposed to be greater than or equal to 16. Well, of course, that's 36. That is greater than or equal to 16. It works. So that means that this point right here that I just drew will satisfy the inequality. So we're actually going to have a ton of solutions that satisfy the inequality because we don't need to just be equal to 16, but bigger than or equal to 16. So for our solution set, of course, we can be on this circle because it says equal to. We actually call this guy the boundary line. So as soon as you write it with an equal and not the inequality, this is our boundary line. We only want to draw it solid if we have the equal to part. And so just a little reminder that when we have the greater than or equal to versus the less, greater than, and less than, this means that it includes that value. And if we don't have that, then we don't include it. So we've kind of drawn this before. I'm going to make it here. The way that everything's related, we've done that whole closed circle thing. And then the mouth with the brackets, that's how all those are related. Similarly with the inequality, we did an open circle and we did those parentheses and we would have a dotted line. So when we're graphing this into variables, we're going to draw a dotted versus a solid line. So now we have here the solid line and we already checked that 6, 0 satisfies it. So the way we think about that boundary is that there's an inside and then an outside section. So if we check a point in one of those sections and it's true, that's what we would want to kind of cover up. So I would like to shade in here everything outside of my function because all the points out here, all of them, will make the inequality true. Now, if it was the other way around, if our inequality had less than, we would have shaded everything inside the circle. So right now, between my little pink highlight and I'll even do it here too so we can see that we want to include the boundary, all of those points will satisfy the inequality. All right, let's try that again. So number 2, we want to graph the solution set. So this time our boundary line is going to be x equals 1. And that is a vertical line through 1. Oh, I did it dotted. It's actually solid. I missed that, the equal to part. So I'm going to make that a solid line I'm just drawing it like our asymptotes here. So this is solid. And then we want to determine which side we shade, because really, again, it's broken up into two sections. We have the left side and the right side. So if we want to see which side that we would be shading, let's read the sentence here. It says our x's are less than or equal to 1. Well, less than 1 would imply everything to the left on my graph, so everything over here. And if we want to like double check with a testing point, then we could say, well, let's check that -1 works. So -1, 0 would be our test point, and we will plug it in. Well, really, there's only one spot to plug in, and the x value is -1 less than or equal to 1. And the answer to that is yes. So you want to make sure you shade where that test point -1, 0 was. All right, let's look at number 3. We have y is less than the square root of x minus 1. So again, we're going to start off with our boundary. And we have that being y equals the square root of x minus 1. And all I'm doing to get the boundary is replacing the inequality with the equation. And then I'll be able to graph this equation. I do want to think about if this should be a dotted or solid line. And because it doesn't have the equal to, that means I don't want to actually be on the boundary. So I'm going to draw that as a dotted line. So this is the square root function. Remember, the square root function shoots off from 0, 0. But we have a little bit of transformation happening here. This is saying we move to the right 1 space. So my graph will be at 1, 0. I'm going to draw that structure here. And it's going to be everything to the right. Now, just a reminder, we can't be anything less than 1 because then that would make me have complex solutions. So I already know that I can't be anywhere over here at all. So then it's really like my radical is breaking up my graph into these two sections, above it or below it, because I can't go behind it. So I need to know which of those sides I'm going to be on. So I can try and read the graph. It says y is less. Less to me kind of means below, but let's check for sure with a test point. So you have to pick a point in one of the sections, either above or below this line. So I'm going to go to this 4. Well, no, let's try something that will kind of come out nice. 5. So I'm going to test 5, 0. If it's true, I would shade everywhere that 5 would be. If it's not true, then I would have to shade everything above. So 5, 0, plugging it in is going to be 0 is less than the square root of 5 minus 1. Is 0 less than, this would be the square root of 4, which is 2. Is 0 less than 2? Yes. So you need to shade where that point is. And so that would mean I would be shading everything down below here. Again, I can't go past the 1 because none of those points could plug in, because otherwise I would get, and we're talking about a real plane here. So got some darker highlight there. Okay, there's our sketch. Okay, we're going to skip over to problem 4. Now, problem 4 has 2 things that we're going to need to graph. And whenever we have 2 things, that's called a system. And in order to be a solution to a system, it must satisfy, so the point that we're talking about must satisfy both of the equations or inequalities anytime we have a system. So I'm going to sketch both of them, and then what I want to see really is the overlap, because those would be the points that satisfy both of them at the same time. So let's start with the top. I have y equals 1/3 x minus 2. That would be my boundary. And I know that this would be solid because of the equal to. And this is actually going to be a line. It's being shifted down to, or has a y-intercept of -2, and it's being vertically shrunk by 1/3, or we could say that that slope is 1/3. So I'm going to go to -2 on my graph, and I'm going to rise up 1 over 3. And I'm going to draw this again as a solid line. If you want it to be really straight, you can keep using that slope. Up 1 over 3, up 1 over 3, down 1, left 3. And we connect those guys together. Again, it's solid because it said equal to. Now this is splitting the plane into 2 sections. There's the section up above or the section below. So I got to figure out which side to shade. And again, we can do it by a test point. So test point, oops, let's undo that. So our test point could be anything as long as it's not on the boundary. So often what I really like to use is 0, 0, just because it's easy to plug in. So when I plug it in, you plug into the original inequality, which would be the top. It says 0 is greater than or equal to 1/3 times 0 minus 2. So 0 is bigger than or equal to -2. Is that true? Yes. So 0, 0 was located right at the origin, so we would want to include that point in our shading. So I want everything up above. We could also kind of read the inequality. Some people like to do that, and we got to make sure we do read it correctly. So let's see. If we read the inequality, it says our y value is greater than that 1/3 x minus 2. So where are we greater than our line? Well, everything up above. Well, it's greater than or equal to, so up above and on the line. So that's the portion that we're talking about right here. Okay, let's sketch the other guy. So this is also a line. Change back to my pen here. And it has a boundary, y equals x minus 4. It's again like our identity function. It's going down 4, has a y-intercept of -4. And we have a slope, even though you don't see it, a slope is 1 or 1 over 1. So to get to this graph, I'm going to go down to a -4 and go up 1 over 1, up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1. And I forgot to check if it should be solid or dotted, so I'm going back to my original, and it is underlined here, so that means it's equal to, so that would be a solid line. And so I'm going to sketch that straight through. And again, I need to decide if my shading for that guy is going to be above the line or below the line. And I'm going to be able to check that by plugging in a point. Again, I like 0, 0 just because it's really nice. So I'm going to plug that in to the original problem. So that's 0, 0. It's going to look like 0 is less than or equal to 0 minus 4. Is 0 less than or equal to -4? No. So that means I do not want to shade where 0, 0 is located. So that's above the line. I want to shade below the line. So that would be everything down below here. We need to stay below. There we go. Okay, and so when we're talking about solving the solution, or solving and finding the solution set, it wants the part that is covered by both. Because right now, if you're on the blue part, you satisfy just the top inequality. If you're on the green part, you satisfy the bottom inequality. But we want to satisfy both at the same time. And so you can see, hopefully, that that overlap is that little skinny, triangular looking thing. Okay, for number 5, now we have 3 inequalities to graph. So let's look at what our boundaries are. So the first equation we have, or inequality, is x squared plus y squared. We're going to make the boundary equal to 100. Now I notice that it says less than, so that's going to be a dotted boundary. And this is the equation of a circle that has a center at 0, 0 and a radius of square root of 100, which is 10. So I'm going to sketch that really quick. So 0, 0, I got to go up 10, right 10, down 10, left 10, and that's a dotted boundary. So it should be a circle, as good as you can get here. All right, there's my kind of lopsided circle. And so then if I think about the shading again, let's do a test point. So if I test 0, 0, that would be in the middle of the circle. So if that does satisfy it, that means I would shade inside the circle. So 0 plus 0 is less than 100. Yep, that's true. So again, that tells me that I would like to shade everything inside the circle. So we're staying inside this guy. So every single point inside this circle will make the inequality true. That's what we're showing by this big shaded region. And so then we need to find the other boundaries. So this is going to be y equals x. And it's just our identity function. The equal to part means that we are solid. So we're going to be at 0, 0, 1, 1, 1, 1. And I'm going to make that a solid diagonal line. And again, we need to decide if we're going to shade above that or below that. And so I'm going to do a test point. Now this time I can't test 0, 0 because that is on the line. So I am going to test 0, 1. Again, it's just like right above it, it's kind of easy. And I'm testing it into the original. So that'll be 1 is greater than or equal to 0. Yep, that's true. So 0, 1 again was right above the line. So for my shading, I'm going to have to shade everything up above. And you can again see my overlap so far, the green and the blue. But we have a third equation now that we want to include. And so its boundary is going to be y equals 1. And so y equals 1 is a horizontal line. And let's see, we need it to be solid because we see the equal to on the original equation or inequality. So we have solid line, all the way across. And again, we want to see if we should be shading above that line or below that line. So are we going to be up above? Or are we going to be below? That's the question. And so we can do a test point. This time I can test 0, 0. So to test 0, 0, really only a y to plug in. So the question is 0 greater than or equal to 1? No. And so I don't want to include 0, 0. And again, if you read the inequality, so going back to the original, it says y is bigger than 1. That would be everything up above. So just by reading it, we can sometimes get what's happening here. So everything up above. Now, because we had 3 inequalities, we want to make sure that we're looking at the overlap of all 3 pieces. So we have to be in that yellow section we just made. We have to be in the green section, which was above, and we also have to be inside the circle. So then that looks like, altogether, we're talking about this section right in here. Now, I like to look at the overlap. Some people can kind of think in their head, like, okay, I should shade above, I should shade to the left and the right, and then they're able to figure it all together. But I kind of need to see that overlap. So that pink highlighted section was a section that we're talking about. Okay, we got one more. And if you haven't been, why don't you pause and try it, and then let's see if you get what I get. So here we go. We're starting again. Again, we start with our boundary. And do that. We have y equals negative x squared plus 7. And that one is going to be solid. And that's a parabola. It's reflected and also moved up 7. So I'm going to be up at 0, 7 now and reflected. So I'm going to go down, and we said it's solid. So we're having some sort of picture close to that. For the next one, I didn't do my shading. To do my shading, again, you could read it. Y is less than that parabola, which indicates below it. But we could do a test point to see. So for my test point, I'm going to pick 0, 0. Again, I just like that because it's easy to plug in. Into my original, that 0 is less than or equal to negative 0 squared is 0 plus 7. Is 0 less than or equal to 7? Yes. So 0, 0 is located below the parabola, so I'm going to want to shade everything inside there. So everything that I'm shading is a point that satisfies the inequality, including that 0, 0. So everything inside here. So then my next one, I have y equals negative x plus 5. This is a line. It's shifting up 5 or has a y-intercept of 5. It's reflected or has negative slope, negative 1 over 1. So to graph that, I'm going to start at the 5 and go down 1, right 1, down 1, right 1. And this guy is also solid because if I look at the original, it has the equal to part, so I want to include it. And so I have that line there. And then for the shading, again, we'll do a test point, and I could be above or below that line. So here's above, or I could be like below. If I read it, it says y is less, which kind of sounds like it should be that lower part, but let's see if that's really true. If I do my test point of 0, 0 into that original, that 0 is less than or equal to negative 0 plus 5. Is 0 less than 5? Yep, that's true. So again, 0, 0 is located at the origin. I want to make sure I include that in my shading, which means I should shade everything down below here, and you could see that overlap so far. The part that has the green and the blue on it. And so then I have one more graph to do, and it's the y is greater than 1. So the boundary for that guy, y equals 1, horizontal line again. And it has to be dotted because it doesn't have that line underneath it. So y equals 1, we're dotted. And it says y is greater. So greater would be everything shaded above. You could do a test point to check that out. So then hopefully right here you can see the part where the overlap's happening. So you have to be above the yellow, below the blue, and also below the green, which makes you this little section right here. That's the part that we're talking about. So every point in that section will satisfy all 3 of those inequalities. Complex numbers.